As I've said many times before, when it comes to these trig proofs, we like to get everything in terms of sine and cosine. The only trig function here that isn't sine or cosine is this cosecant. So let's go ahead and see how we can replace that. You can see in our trig identity sheet, the cosecant is equal to 1 over sine theta. So we'll go ahead and make that substitution as our step number 1. Not going to touch the left side right now. I'm just simply going to make that substitution. So we have 2, make it a bit neater than that. We have 2, and then we have 1 over sine theta. Okay, great. Now, let's talk about this side. So, the left side. We have 1 minus cosine theta and sine theta as our two denominators. We need to get a common denominator. Now, those two are very similar to one of the most common trig identities, this one right here. Let's go ahead and rewrite this identity at the top so we can have that readily available for us. I'll write it in purple at the top. 1 minus cosine squared theta is equal to sine squared theta. Okay? So, what I'm going to do is I'm going to multiply this by 1 plus cosine theta over 1 plus cosine theta. Okay, why? Because it's going to give us a denominator of 1 minus cosine squared theta. Okay, so I'll go ahead and write that as sine theta multiplied by 1 plus cosine theta all over 1 plus cosine theta multiplied by 1 minus cosine theta. Okay, now the next term, because we want it to equal sine squared theta, I'm going to multiply this one by sine theta over sine theta. All right, so that's going to give us sine theta multiplied by 1 minus cosine theta all over sine theta sine theta. Okay, so it's a little bit hard to follow. Basically what I did is I multiplied these two and these two. Okay, now why did I do that? Well, hopefully the next step makes it clear. So when we simplify all these, we're left with sine theta 1 plus cosine theta over, we distribute these out, right? We get 1 minus cosine squared theta. Okay, great. Plus, we'll leave these separated for now. Sine theta 1 minus cosine theta all over sine squared theta. And that equals 2 over sine. Okay, good. So we know that per our identity, 1 minus cosine squared theta and sine squared theta are the same thing, okay, per this identity at the top. So let's go ahead and collect like terms since we have the same denominator. Now I'm going to choose to use the sine squared theta as the denominator. Okay, so this doesn't change up top. We have sine, let's make that a bit neater. We have sine theta 1 plus cosine theta plus sine theta, then in brackets 1 minus cosine theta, and that's all over, again, because we know that they're the same, sine squared theta, okay? And that equals 2 over sine theta. Okay? So, looking at the top, we have two terms here separated by a addition sign. We can factor out the sign. So, let's go ahead and do that. Factor out sine theta. And we're left with 1 plus cosine theta plus 1 minus cosine theta. Okay, all over sine squared theta. Our right side is 2 over sine theta. Okay. Now inside these brackets, we can cancel out this cosine and this cosine, because cosine minus cosine equals 0. All right? Now, we can also collect like terms. We have a 1 and a 1, which is essentially just a 2. So, we can go 2 sine theta over sine squared theta is equal to 2 over sine theta. Our last step, this sine theta cancels out. I'll make that red so it's very clear to see. This sine theta cancels out. The squared cancels out, so we're left with 2 over sine theta, and that of course is equal to our right side, which is already 2 over sine theta. Our left side equals our right side. Okay, so that's how we did that one. Again, pretty easy after you make the substitutions, but yeah, this one's a little bit tricky because there's some factoring involved. Okay, so go ahead and pause that video if you want to see the whole thing, and thanks for watching.